Hi, my name is Alex Williams, founder of the New Stack, and you are listening to the New Stack Analyst Podcast, a show about application, development, and management at scale. Thanks for joining us. Hey, welcome to a new episode of the New Stack Analyst. This time we're recording from our Pancake Breakfast at Dockercon 2016. We'd like to thank Cisco for sponsoring and giving our pancake robot overlord the chance to print some flapjacks from the Dockercon show. Check out Mantle.io, an open source project for building microservices. Learn more at Mantle.io. That's a Cisco project. Check it out. Good morning, Dockercon. Morning. Welcome to Dockercon. All right.
Yeah.
We're so happy to kick things off here. I'm Alex Williams of the New Stack, and we're here for our Pancake Breakfast. We say, come have a short stack with a new stack. We brought PancakeBot along. It's our pancake robot overlord, as Ken likes to say. The whole idea is that, you know, with PancakeBot, I thought, well, here's an Internet of Things device, right? Now our next trick is going to be to connect this thing, right, into the network, right? So we'll have to get to that next. So again, I'm Alex Williams of the New Stack. If you're not familiar with the New Stack, we write about application development and management at scale. We have podcasts. This is a discussion that will be up on our site. The topic today is the New Stack and networking. But before I go any further, I would really like to thank Cisco for making this possible. Let's give a hand out to Cisco for making the pancakes possible and bringing PancakeBot to Dockercon. And so, when we've been covering the Docker and container ecosystem, since our beginning, really, which was about 2 years ago. And when it got started, and I remember the first Dockercon, I didn't actually go, but it was a very small community, and really the focus was like on, many respects on the individual container, and now things have really matured quite a bit, and now we're getting into the whole concepts like, well, okay, now what if you have 100 containers? What if you have 1,000 or 10,000, 100,000, a million? There's even some groups that are using billions of containers. Isn't that right, Ken? Yeah, so in any case, so we want to talk about what are some of the challenges, what are some of, the solutions, what are some of the ideas, some of the concepts, some of the use cases for what this really is about this new stack and networking. And so what we have here is we have a group of people who really know this topic very well, and I'd like to just introduce them. We have Ken Owens of Cisco.
Hey everyone, good morning.
Nicholas Anderson.
Hello.
Simon Richard.
Good morning.
And Brent Salisbury of Docker.
Hello, everybody.
So, I guess the first question I really have is, what is this new stack of networking and why is it so important now? Why is it so vital? Ken, what are your thoughts on that?
I think there's a couple of interesting aspects with networking. One is, I think the industry is starting to look at networking as it doesn't matter. Just give me a flat network space, give me a flat namespace, let me just deploy my apps and let them run. And the issue with that is we learned a long time ago that flat networks cause congestion when you have a lot of issues happen on the network, which if everything deploys and runs perfectly for the rest of your life, you never have these issues, but that doesn't happen, right? Services crash, devices go down, networks have floods of information that happen to try to fix and correct what happened or control. The control plane and the routing plane start talking across the data network, and all of a sudden your data app just comes to a stop. And so there's a lot of lessons we've learned over the past, and I think applying that to containers without making it an overburden on the networking team or on the development team is a key to the new stack.
So Brent, you've been studying this for a while, right? So you came from a company called SocketPlane, and you guys had an approach to this idea of networking. You had a kind of concept of overlay networks that you were really thinking about. How has that changed? How have your thoughts, what have you adapted to in these new market conditions that has changed your perspective about networking in this container space?
Yeah, absolutely. So I got to ask, how many people here would consider themselves a network person?
Uh-huh.
Right, so that's driving a lot of
Okay,
this,
so how
right?
many people consider themselves developers? Okay. All right, DevOps slash operations, developer slash DevOps. Okay, all right, that says it, right?
Yeah, so how many people think the network is important in your data center or in your cloud? So we're kind of seeing these gaps. If we look at the problem for networking in the future and currently really starting, has been starting over the past years, we're seeing a lot of density, right? So we went from, you used to have a server and you would maybe put 20 VMs on it. So you have 20 virtual ports there. So we're basically saying, well, now you replace, the efficiency is there's going to be a multiplier. So now we're going to take 20 operating systems and replace those with, 5x, 10x applications. So each container now gets a port. So fundamentally, we're seeing a massive amount of density that's going to occur. So it's like the old IBM commercials where the data center over 10 years goes from a full room of gear to, the rack in the corner. But that rack is really important. It's really deep. There's lots of density inside of it. So, I liken it to the iceberg. So we see, there's a little bit of physical on the top.
Right.
There's obviously a massive amount of importance around physical networks still. Don't let me discount that.
Right.
But under the hood, there's a whole lot of networking happening inside the server.
One of the questions I have, Simon, is about, you're looking at the market from a much larger perspective, right? And so one of the things that was really interesting to me when I was talking to someone recently, I think it was at OpenStack, was about this whole idea of constructs, right? And identity issues that you have in these new worlds. So you have, for example, someone who might have thought of themselves as a network engineer, a developer is now doing a lot of those jobs a network engineer had done before. And you have different constructs for how people are thinking about networking. Like Kubernetes has one way of thinking about networking. Docker has there's a Docker swarm kind of perspective about it. What are you seeing here? What is your kind of thoughts and perspectives on how this market is evolving and where are we now?
Assuming that all the solutions that are on the market work perfectly, the problem is still how to manage it and who will manage it. Is it going to be the DevOps people, or is it going to be the cloud architect or the network person? And this gap between the developers and the network management team is what needs to be fixed. And it's not trivial at all. In fact, we don't even know who's going to do it at this point. And it's much worse than in the days of VMs. When VMware came, people were pushing back. We don't need VMs.
All right.
Now it's the same thing.
So Nicholas, you're on the front lines here. And you're starting to laugh when this comes out. Is this true?
Right now, we're trying to figure out that very same problem. And luckily, we have kind of a small infrastructure organization to where I can take two steps and heckle at the network guys. But it's really a team effort to figure out what the physical network looks like and how we can combine our overlay network into our Docker world to make something that's scalable and that will sustain us, and something that's configurable in an automated fashion.
So what are the problems you're facing? Just to name 50.
Just to name 50.
No.
Well, to start, a product or a solution to do it. We're still in the building phases. We just built an entire data center, and we're trying to build what our container world looks like. So we're trying to sift through the pile of solutions and determine what's best for us.
Yeah, that seems to be the big issue, is these piles of solutions out there. In the meantime, there's all these vendor battles going on, Ken. What's up with that?
So I think they're kind of related to each other, right? The different choices you have out there are because you as users want different choices. You don't want to get locked in again like we had in the past, right? So you're looking for choice, you're looking for flexibility. At the same time, there's this major change in all of your infrastructures moving towards software, right? Everyone's becoming a software company. And you have to do that in order to get the innovation and the speed that you need to be relevant to your end customers, right? And at the center of that is open source. And so as you look at your open source strategy and you look at networking, there are lots of choices, and it's a lot of complexity. And you have sort of two paths to take. You can kind of go down a path of, I'm going to pick some technologies and I'm going to try to make them work. and I'm going to fight my network engineering team all the way, and I'm going to try to get this all to work. Or you can go kind of a different path and say, I'm going to look for my partners and my solution vendors to provide me sort of a abstraction layer that lets the network just do what the network does, right? You guys probably trust some companies out there that understand the network better than other companies, right? And as a developer, you don't want to be thinking about VLANs and IP addresses and DNS and how you're going to route from one service to the other service, right? But you want the best performance you can get, you want quality of service, you want security, right? And there are solutions out there from partners that you can go to and say, hey, how do I solve this problem? And you can solve that problem by just defining what I call application intent, or a very simple like abstraction layer of what's important to your business. And then the underlying open source technologies will help solve that problem for you and make it a lot easier for the network teams to log in and manage the network, and allow the developers to just write code and deploy.
So Brent, can you explain what the Docker approach is then? I mean, and specifically, kind of for example, that how you guys are thinking about overlay networks, for example, how you guys are thinking about plugins and how these different worlds coexist.
Yeah, absolutely. So obviously Docker has a massive ecosystem of partners. So when we got to Docker, the first thing we did was focus on making everything pluggable. So not only would a partner's plugin be using a set of APIs, we actually use the same set of APIs for our internal built-in drivers. So that was the first focus. The next step was nailing down the overlay driver, because while I love underlay networks, if you're going to deploy on AWS, underlay networks are much less relevant. In this release, we've actually got an underlay integration, something called Mac VLAN. So we're starting to focus on, traditional enterprises that may have a brownfield. They may have a hypervisor that has VLANs going into a server. It's a very, everybody uses VLANs, whether it's exposed or not. So having the ability to capture, a funnel of use cases is definitely kind of our focus. And then, partners like Cisco that have really been driving policy come in and kind of help shape that conversation in different ways. But I mean, the main thing is there is no one network architecture to rule them all. There never has been, there never will be. There's some fundamental questions that need to be answered. Who manages policy? So I think there's been a separation over the past 2 years of routing and policy. So layer 3 down, I think stays for the most part with networking, while layer 4 and up comes from orchestration. So that's really kind of turned SDN on its head to some degree.
So what had you guys been doing before? What was your kind of...
Yeah, so we like when we were at Red Hat, we were doing a lot of controller-based stuff. And we felt the pains of controllers. So networks are very distributed by nature. So having centralized points of failure or centralized points that can't scale to a massive distributed cluster of nodes, which is essentially what networks are, became problematic. So that's one thing that really attracted us to Docker, was the fact that everything is self-contained. We're pushing the problem of how do we get consistent, rather than saying, how do I, from a central point, guess the state of every node in the network, I can now focus on, the only hard problem is how do we keep all the nodes consistent? So, and the great thing is, vendors are seeing the same, the partners are seeing the same thing. You can really have a local focus with a plugin, whether it's built in or not, and everything gets distributed via, some kind of data store, which we have some announcements on.
So Simon, there's been some, conversation about, the traditional networking architectures, and there's been some, people in the networking world who may not necessarily be so pro overlay networks. What are some of the issues that are surfing with traditional networking architectures versus this new kind of, this new model that we're seeing kind of emerge out of the container ecosystem?
Well, as Brent says, there's also two ways to do the container networking. You can integrate with an underlay also, but if you want to use overlays, the main problem with overlays is how to correlate the underlay and the overlay. It works fine until it doesn't work anymore. So You have to troubleshoot problems. I think what's important in Docker networking, going back to is the policies, and is who manage policies. I think there should be like layers of policy and even nested policy. You have the add people who define in the Docker Compose file the network dependencies. Going down, give that to INO, who will add like firewall rules to meet, for example, some compliance like PCI, whatever you need to meet. So it doesn't really matter at this point if you use underlay and overlay. The important thing to think about is policies, and whether you use an underlay solution like Calico or use an overlay solution like what Cisco is doing with Contiv. The important thing is the policy.
Let's take a quick break and then get back to the show. We'd like to thank Cisco for sponsoring and giving our Pancake Robot Overlord the chance to print some flapjacks from the Dockercon show. Check out Mantle.io, an open source project for building microservices. Learn more at Mantle.io. That's a Cisco project. Check it out. Now let's get back to the show. Any questions? Okay, all right. Well, you get a pancake. All right. Let's and you get you get the first Docker pancake that we made here. There you go.
So, question to the policy that you just alluded to. Where do you think should this policy be defined, or by whom? Should that be an admin-defined policy, or should that be something that comes from a user? And if it's both, how do you handle conflicts between those policies?
Well, handling conflict might be difficult, but I think what Docker is trying to do with Docker Compose is to be able to add policy at different stages of the app. You can have policy in your laptop as you use like a different plugin, and you can move and add policies. As you hand off to Q&A, to test, and to operations, you can have different policies. So I hope that's what Docker is trying to do.
And I think in addition to the application level policy, you then have like what the infrastructure teams are trying to define in terms of governance and security and quality, right, and reliability, and what type of data classification. So you don't want to expose that up to a Docker Compose file, right, because that's not something that an application developer should be having to worry about, right? And so you want to sort of have a layer to the point of like nested policies, right? You kind of have the application policy, you have your infrastructure policy, and then you need the enforcement of that policy, right? So what defines and what manages your policy is not the same thing that enforces your policy typically. That way, when you have a conflict, the enforcement point makes the decision, right? And if it's a global policy and you don't allow your local policies to override it, then it would not override it.
So Nick, how are you guys, starting to think about this problem that we're talking about here with the policy issues?
Right now, I think we're trying to figure out how many layers of policy we want to create. We definitely don't want to put that decisioning into the hands of the developers, mainly because they don't actually know what the infrastructure looks like. So we're trying to make a smart decision in conjunction with network teams to create policy at the physical layer and at the orchestration layer.
And I'll kind of just throw in there, where the policy is being executed is also pretty important. So for a long time we had, this north-south model. So, for old guys like me, I remember when 95% of the traffic left the data center and 5% of the traffic stayed within the data center. So that's basically flipped on its head from that north-south kind of traffic alignment to an east-west traffic alignment. But I don't think that means that all policy has to be disaggregated to the edge either. I think there's a lot of money in existing, firewalls, load balancers, that need to be taken into account also. So like having the ability to, just plumb in traditional, whether it's VLANs, whether it's routes. I think there's still a lot of legs there before people start ripping out, a lot of iron and replacing it with. So it's really nice to see a focus on making it dead simple to use.
I think, just to add to that, there's two things to your question, right? One is you definitely, as a developer and an application architect, you want to define what services can be connecting to what services, right? You know your architecture, you know your hierarchy, and so you want to put those things in place for sure, right? The second piece of your question, though, is like, how do you know, like, how does that get enforced from the data center through all the different places you might deploy that, right? And you have to rewrite your application if they decide to deploy it tomorrow in a different data center, right? And so that abstraction layer and the service discovery piece and the service integration pieces are really critical that are coming out, because they allow you to not be locked into just one set of APIs or one set of services, but it'll give you that portability that you need, and still the networking will cover that and follow that where it goes.
Simon, you have any thoughts on that?
Well, that's what I mean by very high-level policy from an application point of view. Just define the services, and that's what the developer should think about. And at some point, as you move them across, the development life cycle, and you operationalize that, then the network people can think about a backend.
Any other developers? Anyone else have a question out here related to networking issues, and maybe seeing with your own microservices development, microservices? Okay, great. Okay, you get a pancake. Hold on.
So my question is quite simple. With the recent release, we're running Elasticsearch cluster, 25 nodes, and we got situation with network like virtual IP for Swarm just has no root to it. Like, it was running okay, but suddenly no root to host, so we had to rebuild this container and reattach data volume, right, with Elasticsearch. So what actually happened? You aware of this issue? Just quick question, Thank you.
So that scenario I'm not sure on. I didn't quite catch all of it. Maybe catch up after this, and awesome. Thank you.
And just in general, like with Elasticsearch and with etcd and other services, we see the IP address and the route just kind of go away. And for those of you who don't know much about networking, I think it's obvious that you would understand that you need a route, you need a network, and you need a way to understand how to get to the next hop, right? And so there's not really any routing natively in a lot of these technologies, and a lot of these technologies are taking the happy path. Like, it's just going to always work, and you're always going to have your route defined. And so
the happy path.
Thinking about scenarios that are going to fail, and thinking about real routing.
What's so bad about the happy path?
Well, the happy path is great when everything works, but everything at some point you have a problem like this where something stops working, and it's not very easy to figure out why.
And the path ain't so happy anymore.
It's not happy then. Yeah.
So Ken, are you announcing a new RFC, Happy over IP?
I think that would be a good one. Happy over IP.
You could go. You hop along. Happy over IP, right?
The Internet of happy things.
Hop down the path. Happy over IP. So all problems solved, right?
Yeah.
Any questions? Okay, great. Hey, Laird. And Laird, by the way, has a PancakeBot and provided critical technique, suggestions here. So thank you. All right, Laird, what's your question?
Yeah. So my question is, I've got developers advocating microservices with dozens or hundreds of Docker containers, one per service, etc., and all the network and management complexity that creates. Are there any tools or infrastructures that'll help with that? Because philosophically it's an interesting approach, but I can't imagine operationally running it that way. But are people doing that, and if so, how are they doing it?
I'm going to let the vendor, not the vendor, but
thanks.
Sorry.
Thanks, partner.
Yeah. That was,
Internet of happy things already broke.
That ain't hopping.
So I think a lot of the vendors in the space are looking at ways to do that, but I mean, you also have Docker has some good tools for monitoring. On the exhibit hall, there's a lot of good tools for helping the network administrators monitor that network. But you're absolutely right. That is a major problem in that today when you send across a request to Docker up something, right? That request just goes off into a black box to most people, right? And it's very difficult to actually track every single step of what happened there. And so one of the things that, a lot of the network companies like Cisco are doing, we're actually kind of hardening, we like to call it enterprise hardening, these different requests and understanding what's happening at the network with each request, what changes are transpiring on the network in real time, and then we're trying to provide the data and the analytics back to the different analytics tools that enterprises already have to help them then sort of correlate these events and know how to fix them right away. And so, and I'm sure Cisco's not the only one working on that. So I'm sure other network vendors are doing the same thing.
Hey, and I'll kind of, please.
But something that exacerbates this problem is unpredictability of the flows. You have application that short-lived, everything moves. It's much worse than VMware. Obviously, much worse than it used to be when you had a classical monolithic SAP application, even amongst multiple services and servers. There's traffic changes all the time. There's no predictable patterns. So it'll make it even more difficult to manage the network, at least the performance.
To the point of what solutions are out there, I think there are plenty of things like Flannel, which make it a lot easier, which use etcd as like a key value to keep track of what's out there. And various other services from Cisco can tie into that. That way, you can deploy microservices at a large scale and still be able to manage both physical and virtual networks.
That's a great point. Well, so I was writing the doc for the Mac VLAN driver at about 3 a.m. this morning and pushed it before the announcement. So, but I actually, put a little paragraph in there along these lines. So while overlays are out there and it is new and the market's definitely trailing, I mean, monitoring is something, unfortunately, as networking as a whole, if you ask most network operators, what's the state of your network, they're not going to know. And it's not because they aren't smart, it's not because they aren't doing due diligence, it's because nothing does more transactions in your enterprise than the network itself. So we're talking about massive amounts of data. There's huge amounts of opportunity around analytics, predictive analysis. But having underlay integrations allows you to leverage what's there today. If you see a MAC address on the network, you know that correlates to a container. If you see a route, you know it correlates to a container. So not much has changed kind of from the operation, administration, management side of it by having that exposure and not encapsulating or wrapping it up. So this is why there is no one network architecture to rule them all.
And for overlays, it's the exact problem as VM overlay. What do you talk about? And for example, VMware NSX is the exact same problem.
A last question. We have one last pancake. We have, there we go. Our Wendy, all right. All right, a quick one.
My question for the panel is, how big of a problem is security firewalling for Docker clouds, and what are some of the current solutions available out there? And by the way, I work for PlumGrid, and we're an overlay networking solution for Docker clouds.
Awesome. All right, anyone?
One of the coolest things that I saw as far as security, or at least limiting what has communication between what, is kind of tagging and linking. That way you can, again, provide policies around containers and allow and deny traffic to various endpoints within your container space based on a set of policies. And all of that is very easily automated as well.
Well, good. That's about all the time we have. So I want to thank the panel, everyone. Give a round of applause for these guys.
In about 10 minutes. Please head to Hall E and F.
I feel like I'm at the airport. And I want to thank Cisco very much for making this possible. Joab Jackson, our managing editor here at the PancakeBot. I want to thank Joab. And everyone, thank you very much for coming.
Thank you.
Thanks.
We'd like to thank Cisco for sponsoring and giving our pancake robot overlord the chance to print some flapjacks from the Dockercon show. Check out Mantle.io, an open source project for building microservices. Learn more at Mantle.io. That's a Cisco project. Check it out. Thanks a lot, and see you again soon at the next Pancake Breakfast. Bye-bye.